How did we depict the Milky Way while we live in it? Hello, welcome all, hope you're all doing well. Many of you have probably seen images of distant galaxies that surround us. These galaxies are typically millions of light years away. Still, we're able to capture clear images of them. Despite the difficulty of this task, it is possible with the use of telescopes to photograph things that are at very distant places. But the problem with everything that we have said is that the image depicts the Milky Way galaxy, in which we are located in the first place. So, how did we photograph the galaxy from the outside while we are inside it? And we're unable to go beyond our own solar system. Hello, my name is Steve. In this episode of Midnight Questions, we will answer the question, how did we depict the Milky Way while we live in it? But before we begin, if you are new to the channel, please subscribe and hit the bell button to receive all of our new videos. Consider yourself on a football field, and all you have in your pocket is the phone you carry with you. If you were asked to photograph the stadium from above and take a panoramic shot of it, what would you do? To take such a picture, simply exit the field and travel further and higher, returning to the Milky Way. Can we use the same principle to depict it? Before we answer, let us see the first machine humans sent to the farthest point in space. Is the distance travelled sufficient to photograph the Milky Way? In 1977, NASA launched the Voyager 1 probe. It is the probe that visited Saturn and Jupiter and sent us pictures and the information it took. After that, the probe's journey continued until it completely left our solar system. And this probe will continue to travel in space until 2036, the year in which the life of the probe's nuclear battery is expected to end. That is why the question that should be asked here is, how far has Voyager 1 gone after all the years it has been travelling in space? After 45 years, Voyager 1 has covered a distance of 23 billion kilometres. Although this is a large number, it may not be enough to photograph the Milky Way from its outside. Our galaxy has a width of at least 100 light years, and if we take into account that a light year is equivalent to 9.5 trillion kilometres, that's 9.5 and 11 zeros. That means that the distance travelled by Voyager 1 since its launch is equivalent to only about 21 light years. All of this means, however, that a distance of 1 light year will approximately need 18,771 years of Voyager 1 probe travelling. In other words, it will not travel 1 light year until the year 20,493 AD. Until now, it has been obvious to everyone that photographing our galaxy from the outside is impossible and difficult. However, this does not imply that the images published by NASA of our galaxy are a hoax or a fraud, because everything we have discussed thus far indicates that we cannot photograph our galaxy in a simple and natural way. For example, suppose we return to our first example and give you a professional camera instead of a phone and ask you to photograph the stadium. You can photograph the stadium from the inside, but from various angles. The image will then be superimposed on top of one another to form a complete picture of the stadium, just like how we do with puzzle pieces. This is exactly what astronomers, physicists and scientists do with the image of the galaxy, but it is worth noting that this matter is not new, and it has been done since the ancient times by several scholars. After all that, due to the development of our technology and the progress that we have reached, scientists in the modern era have completed the work to obtain a picture that is closer to reality and more accurate, of course. People in ancient times noticed that there is a certain thing that appears in the sky at certain times of the year and then disappears. This matter was something like a long corridor dividing the night sky into two halves. There are many different colours in this passage that cannot be counted. It is worth noting that this corridor still exists now, and one can see it if they are in a dark place, like a desert or high on a mountain range, etc. Wadi al-Haytham area in Egypt is one place. People in the past recorded their vision of this corridor, in addition to recording other information about other stars. One of the most famous ancient historical records that talk about the stars and their locations is a book called the Almagest, which is a 2nd century Greek language mathematical and astronomical treatise on the apparent motions of the stars and planetary paths, written by Claudius Ptolemy. Although these are Ptolemy's perceptions, he lived most of his life in Alexandria. They are not completely accurate. They are the main reference for hundreds of astronomers who came after him. Anyway, from Ptolemy's era, we'll go ahead to the year 829 AD, when the Shamsia Observatory was established in what we now call Iraq. The observatory centre was a place for astronomical observations located in Al-Shamsia in Baghdad. This place is considered the first astronomical observation in the Islamic civilization. After that, Muslim scholars began researching, writing, adding and amending books in the field of astronomy and observing stars. Among these scholars are Abdul Hayran al-Biruni, Muhammad Abd Musa al-Khwarizmi, Ibn Sani and others. In this period, Muslim scientists discovered a huge group of stars, which they divided into different groups so that the map of the sky became clearer than it was. And for information only, there are still stars with Arabic names, such as the Sunhail star, Al-Deneb star, Aldebaran star and more. Many years passed after that, until the Renaissance. Between the 14th and 17th centuries AD, European scientists began accurately measuring the sky and determining the exact locations of stars and planets, especially after the invention of the telescope by Galileo. However, Friedrich von Herschel, a German-born British astronomer, was the first European scientist to attempt a complete map of the galaxy. Herschel split the sky into several parts. He then took separate snapshots of the sky from 600 different points on Earth. Next, he collected all the data and information he had obtained, and then in 1785 he drew the shape of our galaxy, which looks like what we see in front of us now, and the shape is called the Herschel map to this day. Anyway, more than 100 years after Herschel's work, the Dutch astronomer Jacobus Cornelius Kapteyn did a similar experiment. But his method was more innovative and creative, especially because the measurement plan on which he relied included the apparent size, spectral type and radial velocity of stars in more than 200 different locations. This is in addition to the cooperation of 40 observatories at the time. In the end, he did get the shape you see in front of you now. However, this continued until 1919, when the American astronomer Harlow Shapley, after studying closed star clusters, declared that the previous measurements and studies were based on the fact that we are in the centre of the galaxy, which is wrong because our solar system is actually located in the outskirts of the galaxy. Thus, all the old maps needed to be modified. Around the same period, in 1920, the most famous astronomer of all time, Edwin Powell Hubble, studied space through his telescope to conclude several amazing things, including the fact that the universe is filled with many galaxies, but for some reason all these galaxies are confined to three main shapes. 1. The first shape is spherical or elliptical galaxies, so that the galaxy is like a huge ball in which the stars are distributed in regular and orderly manner. 2. The second type is spiral galaxies, which have in the middle of them something called the heart of the galaxy. Such galaxies have spiralling arms extending from the centres, giving them a pinwheel appearance. Third, this type of galaxy, they are called irregular galaxies, and they represent the least types of galaxies that have been recorded so far. That is why many scientists have likened the path that appears in the sky sometimes as evidence that galaxies have three types, and by the year 2003, the Spitzer Space Telescope was launched, which is an infrared space telescope that measures the galaxy's wave phases. Through this invention, we are able to confirm that the centre of our galaxy is a collection of red stars and several arms or passages emanate from them. And through the Wide Field Infrared Survey Explorer known as NEOWISE, launched by NASA in 2009, we were able to find out that the centre of our galaxy has two dust lanes emerging from it, namely the Perseus arm and the Scetum Centaurus arm. There are two minor arms and two smaller spurs as well. The Orion spur contains Earth, our Sun and the rest of our solar system. Briefly, through all the data and information collected thousands of years ago, we finally came to the conclusion that what you are seeing now is the shape of the Milky Way, which doesn't have to be 100% accurate. That's all for today, guys. We have answered the question, how did we depict the Milky Way while we live in it? If you have watched it all the way up to here, press the like and share so we can see how much of you have watched the video until the very end. And if you have a question in the middle of the night that is causing you confusion, please leave it in the comments section below so we can answer it, because we make most of our videos based on the questions you write in the comment section.